Morning class, welcome back. Today we're going to learn about solving polynomials, and we call everything we've learned about solving quadratic equations and so forth. The same rules apply here. Now, when solving polynomials, the steps are similar to that of solving quadratic equations. So the steps are as follows. Step 1. You factor the polynomial if possible. Factor it. And make sure it equals 0. Of course, you set the equation of the polynomial equals 0. You factor it. Then you apply the zero product property. Remember, once you factored and you have the linear factors in quadratics, we set each linear factor equal to 0. As a result, here you would do the same in a polynomial of degree 3 or higher. Now, after you apply the zero product property, you would isolate the desired variable, which means if you have x plus 4 equals 0, you get x by itself, and you would get x equal negative 4. So, let us see what we're talking about. Let us consider this polynomial. Ladies and gentlemen, because we want to solve this, remember, every time we hear the word solve, we want the equation to be set equal to 0. So, now, what we do, we set it equal to 0. Now we want to factor it. Now you may look at that and you said, I don't know how to factor a polynomial with degree 4. But this particular equation, you can manipulate it so that it looks something like the quadratics that we have done. In this case, pay attention closely. Look at the x to the 4th power. I changed that so it is x squared raised to the 2nd power. And I bring the rest of the expression down. And the equation rather. So, now, because this looks a little bit odd, what we want to do some type of substitution so to make it look like the quadratics we know. So, we let the letter n represent x squared, which means wherever we see x squared, we're going to replace it by the letter n. And we end up with the following. So it becomes n squared minus 3n minus 4. And ladies and gentlemen, we carry this over. And now this looks like a quadratic equations. Now, we're going to factor this as usual. And we have the following. Now, we're going to apply the zero product property as usual as well. And we have the following. However, I do not want you to to just notice, to rather remember. I would like you to remember that the n was not in the original equation. So what we want to do at this point, we replace the n again by x squared. So we rewrite this so that we have x squared plus 1 equals 0 because we want to find what x is. So similarly, we have x squared minus 4 equals 0. Now, this right here, the first one, you might try to write it as the trinomial that you are used to, but what you will find, you cannot factor this. You cannot factor this. As a result, ladies and gentlemen, you may use the quadratic formula to do this one. However, a faster way to do this, you simply set it equal to 0 and isolate x, and you have the following. At this point, ladies and gentlemen, you would have to take the square root of both sides of the equation. Ladies and gentlemen, we end up with the following. And if you recall your lesson about the square root of a negative number, you should obtain x equal I. Now, remember, square root has two answers, the positive and the negative. Hence, And also, please make sure you know, if you have a complex number for a solution, the conjugate is also a solution. This is why we have I as a solution and negative I. And now, ladies and gentlemen, what we have here, we do the same steps for the second one. And we have it as follow. X plus 0, x squared plus 0x minus 4 equals 0. If you notice what you have, it's a difference of squared. You can do this so you can factor it if you do not know the difference of squares right away as you see it. Hence you factor. And similarly, we apply the zero product property and we get the following. All right? And x equals to negative 2 and x equal to positive 2. Ladies and gentlemen, look at what you have here. What you have here is x equals I, x equal negative I, x equal negative 2, x equal 2. These are the solutions. We have 4 of them. Now, pay attention to this. The original equation has a degree. What is the degree of this polynomial? The degree is 4. And how many solutions we have? We have 4 solutions. Ladies and gentlemen, that is the fundamental theorem of algebra. Given that we have a polynomial with degree of n, okay? If it has a degree of n, that means at most, it has n roots, okay? That means if the degree of the polynomial is 3, the most solutions I can have is 3. The solutions can be real, they can be imaginary or complex, but it will not exceed 3 solutions. All right, this is what the fundamental theorem of algebra states. Now let's look at this one. This equations right here, let's follow the steps. First, we're going to set it equal to 0. Second, we're going to factor. And third, we're going to isolate the variable. Now, when we try to do this, we have the following. X cubed minus 4x squared minus x plus 5. Ladies and gentlemen, you can try to factor this by associative property, by grouping and factor. You will find that you do not have a common factor. So, what is one to do? All right? What is one to do? It is strongly suggests that you apply the rational root theorem, ladies and gentlemen. At this point, you apply the rational root theorem. So, what does the rational root theorem says? Remember, when you have a polynomial, the form is you have f of x equal a sub n, x to the n, and so on, until a sub naught. The rational root theorem says it would be the possible factors a sub naught over a sub n in its simplest form provide you with a 0 of the given polynomial. A sub naught and over a sub n in its simplest form. So, if we look at the polynomial, a sub n, which means the leading coefficient, which is 1, the one in front of x cubed, and the constant, which is 5. So, 5 is a sub 0 and 1 is a sub n. As a result, we would have 5 over 1. So, what we want to do is find all the factors of 5. The factors of 5 are 5 and 1. and the factors of 1, of course, is 1. So, the possible roots of this particular polynomial would be 5, -5, 1, and -1. But keep in mind, there are 4 possible roots. But we know, ladies and gentlemen, this polynomial can only have 3 roots because, ladies and gentlemen, the degree is 3. So, given that we have the possible roots, we would plug these in. Remember, if we plug them in, we get 0. It is a root. It is a 0. Otherwise, it is not. Out of these 4, only 3 will work. We will look further in the next slides, in the next presentation, that will address rational root theorem thoroughly. Thank you. Until next time.